maybe you can enlighten me. There was some hype about like running WASM on the back end, and it sounded stupid as hell to me.
Lane, Boot.dev, you're teaching people to become backend developers. How did it come about? What's the backstory to Boot.dev?
Yeah, I started it in 2020, actually right about when COVID hit is when I launched kind of V0, or I should say I started coding V0 of the project. It only took about 2 months to get the platform kind of to a place I wanted. And I had like demo content that I was building out. And then just another couple months to get kind of the first version of the Go course. It was much shorter at that time. It covered, the very basics of the language. I like to say it was essentially the tour of Go. If you're familiar with the tour of Go, it's this, interactive sandbox that the Go team actually put together to help you kind of learn the basics of the language. It was basically that with answer verification and kind of more in-depth challenges. But other than that, I was really kind of modeling the site after that experience of like, do a small lesson, move to the next thing, do a small lesson, move to the next thing. So it's crazy to think that it's actually been out for 5 years now. It doesn't feel like it's been that long, but I guess it has.
So what was the inspiration? Were you learning Go, or was somebody else learning Go? What drove you to create it?
Yeah, at the time, Go was not as popular as it is now. I like to think that we really helped, kind of spur the popularity of Go over the last 5 years. I've been creating so much content in that space. I love the language. I've been working in it for almost 4 years before that. It's my favorite programming language. Definitely my favorite programming language for anything backend related, and fairly I shouldn't say unpopular, fairly like new, right? Fairly new language and relatively unknown. Like Google was using it, and kind of, I would describe them as like new stage startups, mostly in the United States, were using it specifically for like cloud native stuff. Like if you were working on Kubernetes, there was a higher chance probably that you were using Go. But no, the reason for teaching it was I just noticed that it was really hard to hire Go developers. And we had such an easy time finding people that knew JavaScript, such a hard time finding people that knew Go. And I was a hiring manager at the time. And so I just felt like there needed to be more online resources for learning Go, and backend development in particular. It seemed like, especially 5 years ago, it was really common for someone to get into front-end development through online learning and boot camps, but not back-end development. And I just felt like there's really no reason for that. There's no reason you can't learn, back-end stuff in an online interactive sandbox, just like you can with, HTML, CSS, and JavaScript.
Yeah, I think a lot of the tutorials tend towards front end because you can see what you're doing a lot quicker, can't you? When you put up a web page, and I'm showing my age now, when you got that marquee tag and something scrolled across the web page, it's like, cool, something's happened. There's a motion where, I built a CLI tool, or I built a web server. It's not quite as, people don't get that same kick when you see something scrolling in the console and you've got a bit of a log out that you've received a HTTP request and returned it.
Yeah, there's a big difference between building something that you experience as the user would experience it, which is what front-end development is. Whereas as a back-end developer, a lot of times what you're building, the user isn't going to experience directly, right? It's going to drive some system.
Yeah, it's a lot harder to see and get that same thrill from. I mean, that's why a lot of people, should we say my age, we started with computer games because the internet wasn't around at the time. So that closest thing was, I'm going to clone my favorite game and build a game. I'm going to have little people in here. So again, I hated because I sucked at doing graphic design and graphics, and my games looked awful. So what is it that draws you to Go? Why is it such a favorite?
So I'm not, the smartest engineer out there. And I'm well aware of my limitations. I don't think I'm the dumbest engineer out there, but I you get me in a room with 100 engineers, I'm not the top 1%. I'm not the top 2%. And one of the things I love about Go is just that its whole philosophy is like, okay, we're just going to keep things pretty simple, right? We're going to not have too many fancy language constructs that you need to memorize. We're not going to have 10 different ways to accomplish the exact same thing, right? We're not going to have 10 different ways you can format your code. And so it really kind of standardizes around a lot of the very basic building blocks that you need. And it's low level enough that you can get like almost all of the performance optimizations, right, that you're going to need for a web application without having to like eject into something else, right? Like for example, if you're writing Python on the back end, you can absolutely do that. But there's a lot of times where you kind of have to eject into C to get something done. Like if it's really compute intensive, like you're not going to be able to just stay in Python to do it. Or if you have a Node.js server, again, you can get like a ton of stuff done in Node, but you might need to like make a little service off to the side. Again, if you're doing like something very compute intensive. Whereas in Go, like you're able to kind of stay in Go pretty much all the time with very few exceptions. And they give you access to like fairly low level constructs, right? Like you can work directly with bytes fairly easily. It is a garbage collected language, but most things are stack allocated. So it tends to be very, very performant. So it just strikes, in my opinion, like a really, really good balance between performance and like speed of development, particularly for backend projects. And I would also probably throw CLI and tools in there as well, right? Like TypeScript is famously being rewritten in Go right now. The TypeScript compiler is a CLI tool. Like I think that's also kind of, I think those two arenas are where Go really shines, backend services and CLI tools.
Yeah, I've had a lot of fun over the last couple of months building compilers and interpreters in Go, and it's been a lovely language for that. It's low enough that I can get the performance, but high enough that I'm not really worried about some of the details I would be if I did the same in C. It's interesting you said that, not in the top 2% of the engineers are there, and that Go makes it very accessible. I think that's one of the design goals that they had when they built Go, was to make it an easy language for a multitude of engineers at Google to come in and learn and write very similar looking code in. I think that's one of the reasons I like it. It feels almost as simple as C is, but with the rough edges of C knocked off, with a more complete standard library. Because I think the reason I will never go back to writing C is it drove me mad when I progressed from C to C++, that if I wanted a linked list, I had to go and build it myself for every project, or bring along a library of code I had. If I wanted a hash table, I had to go and build my own, or bring along a library that I'd built before. And all these libraries I built before belonged to the companies I'd worked for previously, so every company would have to build a new one. It's like, why am I reinventing the wheel? I shouldn't be re-implementing a linked list at every company. So when I moved to C++, it was great. There's a list in the standard library. There's a map in the standard library. These things are there. But C++ has a lot more stuff in it, and it has a fairly complete standard library. Go feels nice in that. It's like, yeah, okay, I've got a map, I've got a slice, can cover everything I want. Don't need to overburden that. I've got some libraries for dealing with network and making HTTP requests. So yeah, I can see the appeal. I think it's a really nice, simple enough language. It feels kind of like you took the best bits of Python and C and merged the two in a way. You've got the complete library that Python has, and the ease of access, but with almost the power of C.
Yeah, I think that's a good way to describe it.
Are there any other languages that have drawn your excitement as much as Go has?
So I've been getting more and more into TypeScript over the last couple of years. When I started Boot.dev, I hadn't really ever done TypeScript before. This is 5 years ago. And that's not to say TypeScript wasn't popular 5 years ago, but like it's really ramped up in popularity over the last 5 years. And I started the front end in JavaScript, and we migrated to TypeScript about 3 years ago, and I love it. Like I like Go. I'm a compiled language guy. I like static types. Getting static types in the front end, at least at compile time, eliminated like tons of classes of bugs. Like I still, anyone that says that static types don't eliminate a class of bugs, I think they're just wrong. It definitely does. Like there absolutely are type bugs in your dynamic code that if you just like threw a linter on top, it would catch a few, and like they might be like crazy edge cases, what I mean, but like it's gonna catch them. So anyways, I've been getting into TypeScript, and I just finished writing a new TypeScript course. I don't know when this goes live, but it might be around the time that TypeScript course actually goes live. And so I was digging into like all the internals of the stuff that I've been writing for the last 3 years to build Boot.dev, and really learning the language from the ground up. And I'm really impressed. Like, first of all, it's a huge language. To give some context, like our Go course, I believe, has 15 or 16 chapters in it. Our JavaScript course plus the TypeScript course is like over 30 chapters. Like, I think a lot of times people think like, oh, JavaScript, it's like for script kiddies, it's like the easy thing. No, actually getting really good at JavaScript and TypeScript is actually really hard. Now, you can, of course, get stuff done in JavaScript without learning the whole language and without learning everything that's available to you in TypeScript. But like, understanding the whole ecosystem, like from the ground up, actually is a pretty monumental task when you compare it to Go. So yeah, I would just say that in the last, over the last few years, TypeScript has been where most of like my personal learning has been happening.
Cool. Yeah. And I think that the other thing there is that JavaScript ecosystem moves very, very quickly. There seems to be far more change. I remember initial JavaScript and back in the early days of it, it felt like a very small language. There was fairly minimal ways to use it. You'd write a script on your web page that might be a dozen lines long. Now, there's thousands of lines of JavaScript in a typical web page, and we're building the entire site from that. So there's a lot more to learn. There's a lot more of that ecosystem, and frankly, it's kind of one that I almost find exhausting to try and keep up with, because I don't do enough of it. That every time I come back, I find that it's moved slightly, and it's not that difficult to go and learn again, but it's that much more of a burden that, again, if I come back to some Go code I wrote 2 years ago, I can just compile it, it'll work. If I come back to some C I wrote 20 years ago, I can compile it, it'll work. Look at the JavaScript and like, oh, this has changed and that's changed.
Yeah, you hop into a Go project and the code is always formatted the same, right, with Go format. And you look at like the go.mod or the go. Just the go.mod actually. And you can like see the list of dependencies. And like, that's about the extent of configuration for the project. It's like you've got all the built-in formatting and linting. You've got your go.mod to list dependencies. And that's basically it. You jump into a JavaScript project, like your typical, especially if it's like a front end, or like, I'm using full stack in air quotes because I still don't really think that like Next.js or Next.js are like really full stack frameworks. But regardless, you jump into one of those and it's like you got your prettier config. You've got your ESLint maybe. You've got your TypeScript config. You've got your, if you're in Nuxt, you've got your Nuxt config, right? You've got your Nitro config for the engine that's running the server side. You've probably got some config for like, whatever like automated deployment platform you're using, like Vercel or Netlify or whatever. And so you've just got like this insane amount of configuration right up front, just like to get the whole project off the ground. God forbid, maybe like your Webpack config, or, these days, maybe a Vite config, hopefully, if you've moved off to Webpack. But like, it's just this crazy amount of extra stuff. And so my philosophy is like, man, if you can get really good at JavaScript and TypeScript, at least it makes all that additional crap that you have to add on top to get anything done a lot more approachable, because you're not fighting the actual language constructs as you go.
Yeah, absolutely. So you also mentioned Python. I think you've got Python covered on Boot.dev. What do you think of Python? Have you focused entirely on it for backend, or have you had a little play of using it for AI and data engineering?
So this is like a super common misconception, which is absolutely my fault. But I don't know what to do about it. And it's that like, I don't really like Python for backend development. And that's really confusing to people because they land on Boot.dev and the first thing they learn is Python, and it's a platform for learning backend development. I love Python, for learning programming fundamentals and computer science concepts. Such a great language that just like gets out of your way and lets you write stuff. Right? You want to build a binary tree in Python. You can really just focus on like how the binary tree works, and you can forget about all the crazy stuff of like, even writing the binary tree in Go is like, you actually would kind of need generics to make it work, which thankfully now we have them, but like before you wouldn't have even been able to do that. you have to jump through a lot of hoops. You write it in C, you have to kind of like manually handle all the pointers and allocations and stuff. So like, point being, just if you do it in Python, you can focus on how a binary tree works, which is awesome. So the first half of our backend development track is in Python because the first half of the track doesn't teach backend development specifically. It just teaches programming fundamentals and computer science fundamentals. And that's why we use Python. And then we actually switch to Go to teach all the like how to build a web server, right? And that second part, like I said, we're actually working on a JavaScript TypeScript version of that. So we'll be teaching like the backend specific stuff in JavaScript and TypeScript. So I guess what I would say is I love Python for like, in my life, the only thing I really use Python for these days is like scripts, right? Maybe a Discord bot, maybe a little script that I don't want to write in Bash because, the second I have to use an array in Bash, I kind of don't like Bash anymore. But I tend to write most of my CLI tools and backend services in Go or maybe TypeScript.
Cool. Yeah, I think you're totally right about learning computer science and how to program. Python is a great language for that. And it always amazes me when people talk about going and drilling leak code, that they don't just do it in Python. It's not the kind of immediate first choice for everyone because it is the perfect language for doing that. So why don't you like it for backend? Because I've built quite a lot of backend systems in Python.
I don't think you can't write backend services in Python. You definitely can. I actually started my first job writing Django applications. So I kind of started with Python on the back end. There's a couple just like immediate reasons. Now having like I would say my proficiency in Python and my proficiency in Go are fairly similar. I definitely have more production experience in Go, but like I'm very familiar with both languages. Two things right out of the gate. First of all, like I'm not making like when I choose Go, performance is much less of an issue. Just like I just get that for free, right? My service is going to be, sometimes 100 times faster when it comes to like compute style tasks, just right out the gate. And again, I understand that I can like drop down to C in Python, but like that's a whole nother story. So just performance, awesome. And that's not just like CPU, like speed performance, but also memory performance is kind of a big deal. And I spent a lot of my career kind of as honestly a data engineer than a backend developer. So processing like tons and tons of data through like small pods on Kubernetes. We could literally take a service that was written in pure Python that would take like 100 pods to run at production scale, and like 5 pods with the Go version of the service would handle it just fine. And that's literally like a 20x cost savings reduction to have always on. The other thing is just the static typing. Like dynamic typing is great when you're writing like one function, right? When you're like building a binary tree, again, which is why I really love Python for that kind of stuff. But when I've got like a large system where I'm trying to handle all the inputs and outputs and make sure that the shapes are always exactly what I want, I'm a static typing guy. And being able to actually compile and ensure that my types match is the second biggest reason.
Have you tried then using any of MyPy or Pydantic for type checking on top of Python?
Yeah, the type hints in Python, I think, are the right way to go. Like, I think it's not as safe. Like, the type hinting in Python is nowhere near as powerful as like TypeScript's type checker, for example, on top of JavaScript. But yes, I do think it can help. I have not built a production Python service since type hinting has like really been a thing. The last time I really worked on Django was like in 2017. So I guess I don't know what it feels like in production.
Yeah, it's good and it helps, but the trouble is it's a linter. We're not getting the same effect as if we are compiling Go, for example. So a lot of the Go systems you've built and stuff you're doing for Boot.dev, are you compiling to native? Are you compiling to WASM? What's been the target of it? Do you use any WASM for the site?
So we run WASM on the front end. Like that's how, like when you write Go code on Boot.dev for your lessons, we compile that to WASM so we can run it in your browser. But our backend, no, we compile native and we run on like Kubernetes, Linux. Like, we're not using Ubuntu anymore. I don't think we're using Scratch. I think it's just Debian images. in our Kubernetes pods. I don't understand. Like, there was some hype. Maybe you can enlighten me. There was some hype about like running WASM on the back end, and it sounded stupid as hell to me. Maybe you can enlighten. Like, it felt like solving a problem that doesn't exist. But I have never even been tempted to compile Go to WASM for my backend servers.
I have to agree with you there. I don't think it's something I would do for the back end. I can't see why you would. I was thinking purely about your front end and how you're running the Go. And Python.
We definitely use it. And Python also runs in WASM on Boot.dev. We try to run everything that C as well. We compile for WASM and run it on the front end. Like, that's a great use for WASM. I've seen a lot of articles that are like, oh, it's so cool because you can compile the WASM and run it on like whatever backend server you want. I'm like, I have one. I have a backend server that like it's Linux. Why would I want to introduce a layer of abstraction? Seems insane.
It's also crazy for security. If you compile everything to WASM and run it in the user's browser, if they write any malicious code and they try and, I don't know, run a Bitcoin miner on yours, it's running in their browser. It's not affecting you. If you pull that code back to your backend and compile it, the security aspects of that are absolute nightmare.
Yeah, you have to sandbox pretty hard. And I mean, I looked extensively into how to do that. You absolutely can do it. It's not, I think that's how, Replit, I'm pretty sure Replit runs on the back end. I think Codecademy also runs your code on the back end, just based on my very shallow understanding. I could be wrong there. But yeah, like, you have to do a lot of sandboxing. And it's like, man, the browser's already like so sandboxed. And at the very least, again, like you said, if you're going to hammer the CPU, like, for example, sometimes people do that on accident, right? Like, they write, infinite recursion because they're learning how to code. And it's just like, man, I don't have to worry about the timeouts and stuff on my server. You can burn your own CPU and hit the cancel button when you realize that it's not ending. Right?
Yeah, absolutely. In fact, my older son is studying A-level computer science at the moment, and he literally did hit infinite recursion yesterday on the project I was watching him work through in practice. Again, if you do it in the browser, the other thing about that is the browser is sandbox, but also it's on their machine. You don't have to worry about that. If you start pulling all that back, compiling it and running on a machine, we can sandbox it, but you then own the problem of security, keeping that sandbox up to date, being aware of any other exploits. Bit of a nightmare, really.
Yeah, I'm really glad. And it's funny, WASM was not as popular 5 years ago. But I was very aware of it and thought it was cool. And like, I shipped that very first version of Boot.dev with WASM, like Go compiling to WASM on the front end, which was like really kind of, not a lot of people were doing that. And I've been super happy with the choice ever since.
So did you build all that from scratch, or were there already existing things out there that could, run the compile on the front end in the browser and then run the code itself?
I mean, it depends what you mean from scratch. The Go compiler back then was able to compile Go to like a WASM blob, but that's all you get, right? So I had to like build all the glue around that. So like, I built a custom server that like you give it Go code and it compiles the WASM blob and serves it back. You import it with like a script tag. And to add like a little bit of complexity, we actually do also run the code in a web worker. Right, so you have to communicate through like from the browser's main thread out to the worker that actually runs the code and then gives the result back. So it's actually like a good amount of glue that has to be written. And like, if you really want it to feel, what's the right word, as good as it can feel, you also have to handle things like real timeliness. So for example, in our algorithms course, you'll be writing like, we want to show that things can be slow, right? So you might have a test that does like 100,000 iterations before it actually like prints a result. And then it does like, 1 million iterations, then prints a result. And we didn't want to like run it for 10 seconds and then like dump everything to the console. So we actually have to have that web worker like pipe the results back line by line, just like you would in like when you're running something from the CLI, you actually see, what's printed in real time. So there's a lot of glue code to write. But we haven't like written our own compilers.
But it sounds like there you are pulling the code back to your server to compile it at the back end. You're not.
Yes.
You're not taking a Go compiler that's compiled itself to WASM and running the compile action in the browser.
Correct. And I know there are ways we could do that. But compiling on the back end, there's a lot. It's like, there's like 98% less, security and performance concerns. So that has not yet become an issue. And we do that for Go and C. Python actually is different, right? Because we ship the Python interpreter to the browser and it's the interpreters in WASM. So it just depends on the language a little bit. We support like 5 or 6 languages now.
Cool. Yeah, I think that's a great use of WASM. It's really interesting to see how that works. It's also quite interesting when you see people talk about compiled versus interpreted languages, and then we get this split where people don't quite think that actually whether your language is compiled or interpreted and how it is depends on what you're targeting. Because if we take the examples we just talked about, Python itself has a compiler and an interpret stage. So the Python is compiled to Python bytecode, then that runs on the Python interpreter. Or it can be compiled to WASM and run on the WASM interpreter. And we can do the same with Go, but we can compile it to binary or we can compile it to WASM and then run that on the WASM interpreter. So that's an interesting detail that a lot of people miss about understanding their tool chains. When you get to that level of understanding, you can think about doing some of the things you're doing with Boot.dev. So you've got some cool, interesting new courses and you've got some fairly big names teaching them. Do you want to tell us a few about those?
Yeah, so the last course we released was pretty exciting. It was a lot of fun to work on. So the Primogen, if you're familiar with him from YouTube and Twitch, he wrote a course on the HTTP protocol. And it's almost more of a project, like a guided project, than a course, but it's somewhere in the middle, and we ended up calling it a course because we do actually teach HTTP 1.1, like everything you need to know about like how an HTTP request and response look like, kind of line by line. And then what you build throughout the course is a parser and a server. So imagine building like, Apache or Nginx kind of from scratch, at least the part that handles the request and the part that sends back the response. Or another way to think about it, if you're used to writing like servers in Go, would be like you're actually building the HTTP package. So, you're not using the HTTP package from the standard library, but you're building it. Crazy amount of fun, tons of code, right? You've got to handle it. And like we do live handling of stuff. So, as the data comes across the TCP socket, you're actually parsing it like byte by byte. So like the function that you write can actually handle one more byte at a time and do it in real time. That way it doesn't have to like, you can imagine an HTTP request that comes in is like a megabyte in size. Maybe you don't want to store that whole megabyte in memory, right? So you kind of parse it bit by bit as you go. I'd never done it before. Prime had. Luckily, he was the one that wrote the course. I just helped edit it and produce it. But so yeah, that was a really fun course written in Go. And then our next big project is we've been slowly converting that backend half of our curriculum. So it's like, 10 different courses that were primarily written in Go. We've been converting all of those to TypeScript just because there's a lot of demand. People go through our curriculum. They're like, man, that was a lot of fun. I love Go. Fortunately, like, Go's really popular in like Silicon Valley in the States. And it's like, it's gaining traction, but man, it feels like every job around me is TypeScript. So I'd love to like redo this in TypeScript. So we're making that an option. I hope to have that out like in the next 4 to 6 weeks, but we'll see. We'll see when it actually drops. We'll do a pretty big announcement when that happens.
All right, cool. Yeah, the HTTP one is really interesting. I have a coding challenge. I'm building a HTTP server, and I run my own course on building the Redis server, or a clone of Redis version 1 in coding challenges. And that is an interesting thing every time, teaching people how to parse a protocol, introducing people to the fact that TCP is a stream of data, and you need to look at that stream and parse it and work out where you are in the stream and where one stream or one frame in the stream ends and the next one starts. And that's an eye-opener for a lot of people that have never looked down at that protocol level. And again, the HTTP server is a great one for introducing people. So many people aren't aware of RFCs and aren't aware of how all these protocols are defined. So it's great to introduce people to that and dig into those and show them how these work. Same for N2P and looking at how you do UTP and implement those protocols, or DNS. Those are great ones to really get down a level of detail and a level of understanding.
Yeah, thinking at the stream level is like something that honestly, like as a web developer, you should be doing from time to time, right? But a lot of times we can kind of get away with just like reading the whole response into memory and then like dealing with it and then sending back reading the whole request. A lot of times you can get away with that. But the HTTP protocol can't, or I should say the HTTP package, right? The standard one can't, because it can't assume that you're okay with doing that as the application developer, right? It wants to give you this like ability to kind of stream in the data and handle it. And we actually, like, this is actually a really interesting anecdote. Our servers on Boot.dev, we started to run into some memory issues because specifically Prime did a walkthrough of one of his courses, and there were like 3,000 people watching it concurrently. And then I don't know if you know who Pirate Software is, but he rated, you know, Prime's Twitch channel, so it like jumped up to like 20,000 concurrent viewers, and everyone's loading Boot.dev and everyone's running code on Boot.dev. And what happened was our server would read from disk a full lesson and then send it, like, so it'd read it as a string into memory and then send it across the wire, right? No problem for like our normal traffic levels, right? We're just running a couple pods on the back end. But during this event, it caused some problems. So anyways, we updated that, like that logic that reads from disk and sends it across the wire to actually deal in streams, and like memory, you know, memory utilization dropped like a rock. And so it's that kind of stuff. Like that's the kind of practice that you're getting when you work on, you know, the courses that you're describing on coding challenges, or like this HTTP course on Boot.dev.
Yeah, and you've got to get down that level of you know, building something a bit lower level to really understand that, which is why I like digging into these servers and building things like that, because it exposes you to that depth. And same with building an interpreter and compiler, which I did at university 20 odd years ago, but revisiting it a lot over the last year or so has been a lot of fun to get back into that. And compilers and interpreters are kind of real computer science projects of you getting down into nitty gritty of what it means, and using some of these algorithms and data structures at a low level. Good fun things to do. The flip side of that, AI is a hot topic today, and it doesn't seem a day goes by without somebody saying to me, well, coding challenges are cool, but why do I want to learn code? Because AI is going to replace all software engineers in 6 or 12 months' time. So I'm sure you get that a lot as well, Lane. What are your thoughts on AI replacing us?
Yeah, it's really funny. We get a lot of comments on social media about that, and it's always from someone who has no skin in the game, right? It's always someone who's not actually a developer, who's just like, and like the level of confidence with which they say like AI will replace coding developers is directly proportional to like their inexperience in how web apps work. At least this has been what I've noticed. Like once someone's like a little bit, you know, more into their education and learning, they might have a little bit more nuanced take. It's like, oh yeah, like how we write code is maybe changing, right? The things you need to learn might be like prioritized a little bit differently. But the like AI is replacing all developers, and it's crazy you don't know that yet, is like always from someone who's never coded before, at least in my experience. So yes, do definitely get those comments. I hired an engineer last month because we have a lot of projects. Like we're now up to 6 engineers at Boot.dev. And so to me, it's like just very straightforward of like, when I can offload our backlog of engineering tasks to an AI, and I don't have to like hand it to an actual engineer, and they are using AI, like all the engineers on my team have ChatGPT licenses through Boot.dev, right? They have Claude Code, agentic experiences that they can use. But like, I'm nowhere close to being able to like say, hey, AI, please take a look at my Kanban board of backlog and just like start knocking out these tickets. Like we're just not even close to that. So like I'm still hiring engineers. I don't see how any other company wouldn't be as well, assuming they're growing. My take is still the same that it's been for about the last year, which is AI is awesome. Use an AI. It's not good for everything. Sometimes it produces shit. You got to watch it pretty close. But the important thing is like, I still don't think that like the developer recession is very correlated to the boom in AI. I think it's very much more correlated to interest rates and the economy in general. I think it would be really interesting to see what the landscape right now would look like with interest rates at like 3%, like they were in 2020. Because I think that would be very different.
Yeah, I totally agree. And the newsletter Pragmatic Engineer had a post a couple of months ago, I think now, looking at the effect of AI and the effect of interest rates, and it correlates far more highly with interest rates, the dip in jobs we've seen recently.
I need to go read that. I'm not even aware of this article, and it sounds like I came to a similar conclusion.
Yeah, have a read of the Pragmatic Engineer. I think it's one of the biggest paid newsletters on Substack. And yeah, I'm totally with you. AI is very useful. There's a lot of useful tools we can get from it, but it's not replacing us anytime soon. And I find it particularly amusing when people say, we're going to better just describe our code in English. I don't know about you, but that's been the biggest bugbear of my career, trying to get somebody to describe in plain English what they actually want us to build.
That just was doing like a crazy amount of heavy lifting. Just explain it in plain English.
Yeah, and so I haven't met a product owner, product manager, business analyst who can do that well. I certainly haven't met a software engineer that wants to sit down for hours and work out, how do I write out all my requirements in English unambiguously? And even then, it's very hard to be unambiguous in English. Go and look at, mathematics, physics, any science. They have scientific notation because it's precise, it's unambiguous. We have code because it's precise and unambiguous. So I think we're always going to have some level of needing something that is more precise and less ambiguous than a natural language.
As your expertise in a topic goes up, you yearn for the more precise version, right? It's kind of like how when you're first learning math, new mathematical concepts, like the Greek letters and the crazy symbols are just like, why do we do this? This is so confusing. But once you learn what they are and you're talking to another mathematician, like you're going to communicate way faster by handing them a formula that describes what you're trying to model rather than like a giant paragraph of text that describes in English what you're trying to model. And I have very concrete examples of this on Boot.dev where it's like, okay, we've got a 3-line Python function and I have to write the explanation to the student of what it does and how they can write it from scratch themselves. That explanation is longer 9 out of 10 times. Like it's almost always going to be longer. And like you said, it is more ambiguous. As you gain the skills, you actually usually want more precision, right? And I think that one like very overlooked bit of this, and it's something that we're leaning into a lot on Boot.dev, is like AI is really good for helping you grok things and understand things. It can take a very precise thing, right? Like, a well-written function and kind of walk you through what it's doing step by step, line by line. And so I'm not like an AI Luddite. Like I use AI all the time. I have it explain things to me. I'm pasting in stuff. Like my chat window is basically always open. But my take is that it will very much influence different ways that we gather the information we need to use as engineers, that we learn in general. But I think we're quite a ways away from like the autopilot of just giving an AI agent a business goal and telling it to go off and do its thing.
Yeah, it's going to be a great tool for increasing productivity, but not a replacement for software engineers anytime soon. Cool. We talked about a lot there, Lane. Anything else that we should talk about?
No, I think we hit the main points we wanted to talk about. You were awesome enough to let me plug Boot.dev, plug our most recent courses. Like I said, TypeScript version coming out. I'm always available on Twitter, LinkedIn. You can always @ me. Those are probably the 2 socials that I'm most active on, is Twitter and LinkedIn. And then, of course, if you have any questions specifically about Boot.dev, anyone listening can always hop into our Discord and ask there. But no, this has been a really fun conversation. I appreciate you having me on.
All right, awesome. Thanks so much, Ryan. Been great having you join us.
Thanks.